Let's look at some rule of V's for geologic maps. I've talked a little bit about these, and they're different for topo maps. Remember, I think in the video that eScience Labs has, there's a good explanation of the rule of V's for topographic maps. But for the rule of V's for geologic contacts, the rule here is that in fact, we'll see the close of V points in dip direction. Points in the dip direction. So when I'm looking at these, I see that obviously I have some sort of plunging fold here, right? And I see that the strata on the east side over here, remember they're always going to strike here parallel to the contact here, but I see they're dipping toward the east because that's what the rule of V. Because in fact, I didn't show you what this is. This symbol of a dash, dot, dot, dash, dot, dot, this is a stream. So whenever one of these contacts crosses a stream, we're going to make these V's, right? Whenever you cross a stream, you'll make a V. And so here you can see that we'll show our strike parallel to the contacts but dipping off toward the east, strike parallel to the contacts dipping out to the east. Now on the other over here you can see they're dipping off to the west. So strike and dipping this way, strike and dipping that way, strike and dipping that way, right? So we see that we're going to have some fold here. So if we draw the axial plane, so I'll put AP for axial plane, and I'm going to show that the strata are dipping both away from the center, right? So this is going to be some sort of anticline, because that's my symbol for an anticline, right? But I'm going to, this is actually a plunging anticline, so I need to figure out whether it's plunging toward the north or plunging to the south. So we'll figure that out in a moment. But the next thing we want to do here, we want to make a cross section. So in fact, this line X to X prima here is called the line of section. And I want to see, just like I'm cutting through a birthday cake, I want to see the layers, what they look like underneath. And so the way to do that is you'll need a separate piece of paper, and you'll place a piece of paper on the line of section. And then you'll want to mark where X prime is over here and where X is over here, so you know where those points are. And then whenever a geologic contact crosses that line of section, you're going to put that contact there, right? And then this one, since I know formations B and formation O are dipping off toward the west, I'm going to show that they're dipping off in that direction there. And then this contact here between formation O and formation T is also, according to this rule of V here, is also dipping off toward the west, right? And then I have a contact here, and I see that that's also between L and T is also dipping off toward the west. But now when I go to this contact, I see that these are dipping off toward the east, right? So these are going to dip off this way, and this contact's also going to dip off toward the east, and so are these other ones here, right? So now I'm seeing my contact. So this is formation B, this is my formation O, here's formation T, this one in the middle here is formation L, and then I got T again, I got O, and I got B again, right? And so I'm going to show the structure here. So let's kind of make a box here to complete our diagram. And so we'll show that this fold is going off in this direction. So here's our anticline that we're mapping. And we usually try to keep the general same thickness for the formations here. So there's our showing our structure. Now, one thing that we can't forget is that remember, one of the rules for the anticline is the older units are up against the axial plane. So here's my AP, my axial plane. But I see that on the map there's a unit H down here, right? And unit H is on the axial plane, so it's probably the oldest unit here. So I'm going to put in here that there is another unit down here, even though it doesn't show up on my line of section. I know it's down there, so H is down there. And then I would color it with the appropriate colors, and we'd have a cross section. So you'd be doing something like this in the lab for this week. Now this map here is an important one, and it's an example that I want to use because I'm going to give you a different one for you to do in this week's lab. I'm going to color some of these units in just to kind of give us an idea of what's going on here. Okay, now I've drawn some of these units in, and what I want to point out there's a formation B up here, and this one is nearly horizontal. It's dipping off toward the north west at a very shallow angle, so it's relatively flat. And these symbols indicate that it's a unconformity. So in fact, it's an angular unconformity because these guys are tilted, folded, and this is really not. And then I got a formation Q up here that I colored in blue, a formation A, which is this sandstone unit here, and I got a formation R here in red, and then I got the intrusive diorite over here, and I have my fault. There's a fault here, and you can see it's dipping off toward the east at about 60 degrees. Now, the other thing I want to point out is I got the stream, see the dash dot dot here and dash dot 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 here pattern. So, and I can see that there's some rule of V's going on here, right? And so let's put some strike and dip symbols. So right away when I look at this unit formation A, if I go to the stream, I see that it's dipping, it's striking parallel to the contacts, but it's dipping down in this direction, right? Because it's showing me it's dipping down toward the southeast over here, right? This fault is also dipping in that and off to the east. So one of the first things I want to draw this fault in because it's it's gonna cut younger strata, so it's going to be a marker in this formation. And in this one, note that I've already provided you with a cross section x to x prime down here. So again, I'm gonna find out where the contact occurs with that fault right here and bring it straight down onto my cross section here, right? And it's going to intersect here. Now I'm going to have it inclined about 60 degrees to the east. So if I have this horizontal, I'm going to go down until I get about 60 degrees. So there's 50, 60 is right around there. It doesn't have to be perfect, but you can see if I drew a horizontal line from here, I'd go through 60. So I'm going to show my fault that's inclined down in this direction here. All right, so there's my fault, dipping at that angle. Now I'm going to show the contacts. But one of the things that's missing over here, I don't know where the contact between formation Q and formation A are underneath this, this formation B. So one thing that geologists do is when younger formations cover older geologic contacts, we usually dot them in. Underneath this formation B will be this contact that lies in there. So now when I draw that in, I can show where that is. But first of all, I see that my topography here shows that I have this ridge here. So this is going to be formation B right here. So that's a relatively flat line unit. So, and then under that, I'm going to have my first contact. So there's my first contact, which is, this was going to be Q over here, and this is formation A here, right? Then my next contact is right in here. And then you can see that because this is dipping this way, and this one, as I move this around, this is going to be, should be striking like this, but also dipping off this way. So these formations are dipping in off toward the east like this. Then as I go along here, I'm going to find between formation A and formation R is right here. I bring it right down here. There's my creek right there. So I'm a little bit to the east of the creek, and that's going to be dipping off this way. So what I'm going to find here, and this is formation A down here, I'm going to find that this is showing a syncline here, right? Where this is formation R right here, and formation A is underneath it. And remember, I'm going to try to maintain that same thickness for A, try not to change that too much, showing that this is probably that flexural slip here, and that's going to abut against the fault there, right? So, and then that means everything underneath is going to be formation Q down here, right? Formation Q. Now, if I go to the other side of the fault, I see a formation R here and A here, and the contact is right here. So I'm going to drop this straight down here, and I see that based on the strike and dip symbol here, these units are dipping off toward the west, right? So I bring this contact here and to show that this is dipping off toward the west. And so then I bring this contact here, other side of the tree, and this is also dipping towards the west. So this is formation A. And then as I move around here I see that they're dipping off toward the east on this side. So I bring this contact in here, and I show that it's dipping in this direction. And then the contact, again, was intruded by this diorite, but I'm going to show that it should occur in here somewhere. And that's going to be also dipping off in this. So this is my formation A. Then I got formation. So this in the middle is formation Q, and this formation R over here. And I got a little sliver of R. So I'm going to color R in just to see a little better here. So now I've colored the units in, and I can see I have a syncline and an anticline over here. And then for the intrusive relationships, I'm going to show that the contacts are occurring in here and in here across my line of section. So there's probably some intrusion of a diorite that came in here, and so that'll be my diorite that came in later on. So that's a younger unit, a unit that intruded based on cross-cut relations, this unit over here. So let's answer some questions on this. So we figured out the formations here, right? And we want to figure out the ages. And so assume that formation B contains pebbles of diorite formations, and which means the formation B, based on the principle of inclusions, must be younger. So the oldest unit here must be formation Q. That's the oldest unit because it lies at the bottom here. And then it should be formation A. Then we have formation R. And then we're going to have, and then the next unit probably is going to be the intrusion of the diorite. So I'm going to put the diorite here. Although one of the problems is I'm not sure whether the diorite or the fault is older, but probably intrusion and tectonics probably were similar, but I'm going to put the diorite a little bit older because that happens at deeper levels, right, this intrusive. And then we're going to have the fault here. And the youngest unit is going to be formation B, the relatively flat line unit up over here. Now, in the cross-section, does a fault appear to have normal or reverse offset? So that would be a normal fault. So in our lab, we'll have a similar, in fact, I'll show it to you. In lab, you're going to solve a similar problem. This is the one I want you to solve. You see there's some rule of V's going on here. And make sure you follow the directions. In fact, this word attitude, that means strike and dip. That's one thing I didn't talk about, but that means strike and dip. So you want to put the strike and dip at all these points. So you can see that point A, point B, point C. One thing about point C here, which I haven't really discussed, and now that I notice it, is note that when the contact crosses a stream here, they do make V's over here, but note that there are no V's forming right here near point C. If there's no V, so no V, I'll put a question mark there, that means we have vertical dip. So you would want to put a strike and dip symbol that looks like that. Remember that symbol? The strike and dip symbol. So when a geologic contact crosses a stream valley where there's no dip, that means that this is vertical strata. And now over here, they do give us a strike and dip symbol. So this is the one I want you to work on for the lab.